Hello everyone, my name is Sarang Borude and I am back again with a very exciting tutorial for you all. This time we are going to use our Apple Vision Pro to control the lights in our home. My original plan here was not to make a light control app. I was just keen about ARKit World Anchors. ARKit World Anchors in Apple Vision Pro are a very interesting tool that allow you to create persistent experiences across app and device reboots. That means that when you place a virtual object in your space, even if you turn off your headset and put it back on, the object stays there. It's a very important idea that creates the bridge between the real world and the digital world, and that's why ARKit World Anchors are really cool. So I was really fascinated about world anchors and I just wanted to play with them, and then I realized light control would be a cool application of persistent virtual objects. So I started playing with it and this whole tutorial came to be. I am going to divide this tutorial in 4 parts. In part 1, we are going to dive deep into ARKit World Anchors and see how we can create persistent objects or entities that can even last across app reboots and even device reboots. And then we can see how we can create entities that are attached to these world anchors that are associated with our lights so we can control our lights with them. In the second part, we can see how we can create UI that we can use to change the color of the lights. In the third part, we'll get a little bit more playful and create a slingshot mechanic that we can use to simply aim at the light and basically change the color of the light whenever this sphere or this orb hits the light. And finally, in the fourth part, we'll dive deep into how we can create this ring of orbs that you can simply hold your hand up, pick an orb from it, and simply drag and drop it on the light to change the color of the light. So there is a lot to learn here. We will be looking into ARKit, ARSession, WorldTrackingProvider, World Anchors, and RealityKit, and a bunch of animations. This tutorial is more of a code walkthrough than a code along, so make sure you download the project from the GitHub repository link that is shared in the description, and you explore the project as you watch the video. I hope you are as excited as I am for this tutorial. This is going to be a little bit dense, but trust me, I'll try to simplify it for you. If things don't make sense, please leave a comment below so that I can follow up with you and try to simplify it even further. But let's jump into it. We'll start by creating a new app. I'm calling it Light Control Tutorial, name it whatever you want. And these are the settings I'm having for immersive space render, immersive space, and initial scene. So once the project opens, you can see that our app is pretty empty right now. We have a content view, we have an immersive view, and we have our app model. Let us begin with adding all the Philips Hue code. I'm not going to dive too deep into the Philips Hue code because that is not important here. You can swap out the Philips Hue code with pretty much anything else. So I added these 4 files here: the Hue Bridge Discoverer, the User Manager, Control Manager, and Local Discovery. We are basically going to take a very high level look at what these files are doing. All I did is I went to developers.meethue.com and there is this nice guideline of like how to do bridge discovery and how to like control lights. So I just went through this one page, and based on what this page is describing, I created a wrapper around the API of Philips Hue. That's essentially what these 4 files are doing. You don't have to really worry about it. You can copy paste the code directly, or you can replace these 4 files with, let's say, HomeKit and control accessories with it. So these 4 files here will allow us to communicate with our Philips Hue bridge, and once we have established that connection, we'll be able to control the lights. So I'll tell you what exactly these lights do. So first we need to figure out the IP address of your Philips Hue bridge that's in your space, and it needs to be on the same Wi-Fi, the local Wi-Fi on which your Vision Pro is. There are 2 ways to discover the IP address on your local network. One is using this protocol called MDNS, and it basically allows you to figure out what is the IP address of this device on the local network. Then the second way is Philips Hue also provides an API endpoint which basically has stored a pairing of like your local Wi-Fi router's IP address and the Hue bridge associated with it. So whenever you make this API call, it will give you the IP address. So essentially these 2 files are redundant. They're doing the same thing. They're just trying to get the IP address of the device. So your app now knows the IP address of the Philips Hue bridge, but it cannot simply use that to control the lights. So you need to do one more step, that is do some kind of authentication with the physical Philips Hue bridge in your home. The way Philips Hue does it is it wants the user or the app to do a handshake. So the user kind of goes and presses the physical button on the Philips Hue bridge, and then your app will make a call to request a token. Philips Hue calls it a username, but it's essentially a token that you use in your API calls to control the lights. That's all this is doing. Once we have gotten the token, we simply store it in something. Maybe you can store it in user defaults, or you can store it in core data, or the best way to do it is storing it in the keychain. It's the most secure. So here I'm using the secure keychain to simply save the username or the token that I'm getting from the Philips Hue bridge and storing it in this file. I'll give you a very quick overview of what this file is doing. So let's first look at this function called ensure authorize, because this is the one that gets called. So first it basically checks that do we have an existing username in the keychain. If it is, then we simply toggle this flag to true. If not, then we'll have to make an API call. So the actual API call is defined right under, and it's making this API call, and then you'll get a JSON response from it, and the JSON response, you're simply extracting the username, and if you cannot extract it, you will basically provide errors to the user so your app can show the right state to the user. So that's essentially what's happening. Once you finish the call and you get a response and you got a username from the Philips Hue bridge, you store it in the keychain. So there is this line of code that basically allows you to store it in the keychain. You will probably ask, okay, where is this code to like store the files or store the username in the keychain? Right below. So you can see here in the keychain management section of this file, it will allow you to store username in keychain and also retrieve it. So these are the functions that allows you to do that. Now your app should have the IP address and the username you need to control the lights, and Hue Control Manager is the class that we are going to use to simply start controlling the lights. First, we need to discover what lights and groups are available. So I have some functions here that you can use. So find lights and groups kind of finds it in one go. Then there is separate functions for like finding lights, and there is functions for finding groups. Groups are basically, if you have defined rooms, they are basically sorted as groups. Okay. And then there are functions like control light, and here you can pass an ID for the light. So this is a number associated, or you can do it in a little bit human friendly way where you can pass the name of the light. So this is what I prefer. Same thing for controlling groups. So you have a control group function, but then there is a user friendly sort of control group with a name of the group. So like living room or bedroom. There are some functions here to get the status of the light, like is the light on, is it off, what color it is, so you can retrieve that data as well. So it's just like a bunch of API calls. So these 4 files basically allow you to get the IP, store the username, and once you have gotten that, then finally control the lights and the groups in your home. So you probably saw that this app kind of does a lot of API calls, and to allow our app to make all these API calls, we need to add something to the info plist of the app. So you click on the name of the app, and here you can go into your info plist, and here you need to add this entry which says app transport security settings, allow arbitrary loads, and you have to set it to yes. This is very important. If you don't have this, you will not be able to discover the IP address of the Hue bridge or be able to make network calls. So make sure you add this or your app will not work. I've added some code to our content view that basically allows us to control the lights using the APIs. So here you can see I've gotten the handle of the instances of our singletons for our bridge IP discovery and the usernames discovery. And then our control manager is probably the main one that we'll play with here. It's plainly Swift UI here. So you can see that I have some UI that kind of tells the app name is Philips Hue Control. I can display the discovered internal IP address and also the local IP address. These two should ideally be the same. Then I'm doing some state checking, like for example, if the Hue Bridge manager has discovered the username, then it basically displays the text of the Hue Bridge username is already found. If not, then it will present a button that the user should press, and then we make this call to the ensure authorized function that will retrieve the username. Then if the username is discovered, we are also showing two buttons. One is load lights, other is load groups, and here we are using the Hue control manager to simply find the lights and find the groups. And once they are discovered, we are setting this flag to true. So once we have discovered the lights and those flags are set to true, what happens here is you create a scroll view, and each scroll view will basically show the name of the light and creates two buttons by it. One is the on button, one is the off button, and each button, when it gets pressed, will again do a call to Hue control manager to turn it on or off. And the same thing for the groups. If the groups are loaded, for each group we are creating some buttons that will allow us to basically show all the groups, two buttons in front of them, and you can turn it on or off. Now that we have this code, let's try running it. Oh, one more thing, there is this function here, handle control results, because it kind of takes a completion handler. So here I have defined that. So the completion handler basically handles like the error messages or the success states, okay, just to keep things clean. So that's our content view. That's all we are doing in it right now. Let's see if all the code we have added to our project will allow us to control the lights or not. So when our app launches, we get this prompt that asks us if we want this app to allow to find devices on our local network. You press allow, so we can discover our bridge. And then when the content view loads, you can see that the UI will show us the IP addresses discovered by both our IP discovery managers. So what we are going to do now is we are going to walk to our Hue bridge and press the link button on the bridge, and then press the connect button. So here you can see that it says username found, and that means we have a token, and then we can press the load lights and load groups button, and this basically means that we can now figure out what lights and what groups exist on our Philips Hue bridge, and then we can press the buttons to control them. So let me try to turn those on and off. And using the groups, we can turn on and off the whole room. Here's me turning it off, and then I can also turn all of the lights on in one go. So yeah, I mean, we can control the lights, but this is not cool. We kind of want to actually interact with the lights rather than doing it with the UI. So let's see how we are going to do that. So it's important to understand that your Apple Vision Pro is basically creating a map of your space as you keep using it. And it knows whenever you are in a particular room or whenever you go from one space to other. Let's say you go from your home to your office, it remembers those are two separate different maps, right? So your app can essentially create persistent locations in this map. So we can do this using ARKit and world anchors. A world anchors is nothing but a transform and a unique identifier associated with it. So your app basically tells visionOS using ARKit that, hey, can you please remember this location for me? And the world anchors API basically tells you, okay, perfect, I've remembered this space for you. Here's a unique identifier for that space. So let's say you force quit your app, or let's say you turned off your device and you turned it back on and you are in the same space. So when your app launches and goes back to immersive space, visionOS through ARKit basically tells your app that, hey, I think you are in the same space and I think you have asked me to save some points or locations in this space. Here are the unique identifiers and a transform for the world anchor you asked me to save. So now your app now has this persistent location transform that the OS has basically provided your app, and now you can do whatever you want with it. So you can be like, okay, great, now I think there is this location, I think I created a sphere that controls the light, and I'm going to basically reset its properties so that I can control the same light with this sphere again. And the key part here is the unique identifier for the world anchor, which really enables it. So we need to know what is the position and what is the unique identifier associated with it. And in the app, you're creating some persistent memories, like basically which particular light is controlled by this world anchor and how do we want to represent it to the user. So you get to control how you're going to represent this data, this location, and then you get to control how your app basically behaves around it and creates an experience around it. You can do really cool stuff with it. Imagine you're creating a virtual pet app, and then you create a home for this pet, which is going to be in a specific part of your home. Let's say it's a bird, and you create a nest somewhere in your space, and then the bird basically comes out exactly from the same nest every single time you put on your device. Now this is very cool to create very believable experiences that really bridge the boundaries between the digital and the real world, and really cool. So World Anchors is actually a very cool feature in ARKit that you get to access in your Vision Pro apps. So the whole point of this tutorial and this app is basically to understand what world anchors are, why are they important, and how you can create persistent experiences that last across reboots. So before we jump into the code of how to do this, first I want to show you what we are going to make. So here's the content view. Now it has a show immersive space button that you have already seen, but now I press it and you see that your app now enters fully immersive space. That means no other apps can run besides it. You also see this toggle here which says edit lighting setup. When you enable this toggle, you see some buttons to add light controls and group controls. Now when I press add light control, a red sphere appears in front of me. It's a reality kit entity that I can now position over the lights. Also notice that the sphere kind of disappears for a second when I release it, and we'll talk about it in a little bit. But the red color represents the controls for the right. I can simply add a group control as well, and that is represented by a green sphere here. So these spheres here, they are simply entities, but they don't really know which light they are associated with. So you can do a spatial tap gesture and a menu appears, and here you can select which light it controls. So this one controls living room big 3, this one will control living room 3, and this one controls all of the living room. So once you have done that, and when your app gets out of the lighting setup, so now these spheres can control those lights. When I do spatial tap gestures, the group one, when I tap on it, it controls all the lights in this space. So another thing here is that when you enable the toggle for editing lighting setup, the orbs or the entities, they become less transparent, and when you disable it, they become more transparent. So we are going to do that as well. And one more thing I want to show is when I force quit the app, and I open the app again and hit show immersive space, our entities load again and they can still control all the lights. Alright guys, now let's jump into the code and see how all of that is done. So you can see that I have added a bunch of different files in this project and I have organized these files into different folders like views, view models. We have one component that we are going to create that lives in this ECS folder, which means entity component system. That's about it. We are going to look at all these files in detail. So don't be afraid that, oh, I added so many files right now and it's going to be very intense. I'll try to simplify it for you. Let's just first talk about the content view. Here we added in the content view a simple if statement where if the app goes into immersive space, you are presenting this toggle to the user that says edit lighting setup. And then when this toggle is enabled, we change this flag of is editing lighting setup, and that presents three more buttons: the add light control, the add group control button, and remove all controls button. That's basically the changes in the content view. So you can see that I'm referencing the app model a lot of times. So that means a lot of code changes have happened in the app model. So let's take a look at the app model. All right, guys, the app model. This is going to be the most important file in this particular project. This is where we are handling all of the ARKitSession, your WorldAnchor handling. So we'll spend a lot of time here. But I cannot talk about the app model in isolation. We have to really go in between the content view, the immersive view, and the app model and see how they interact, and then only you can make sense of like how this thing is as a whole stitching together. The most essential framework at the center of all of this is ARKit. ARKit allows us the access to WorldTrackingProvider, and then using the WorldTrackingProvider we can basically do world anchors. Let's talk about the app model, the immersive view, and the content view, and how they all sort of interact with each other. Okay, so I guess the main idea of the reality view is basically to create a view that presents the reality view entities to the user. So anything you see, the user sees, is presented using the reality view. Here you can see that I have this line of code that essentially calls appModel.setUpContentEntity. Let's look at what this is doing. So I'll go into app model now, and here you can see that I have this content root and it's an empty entity. Here you can see that there is this setup content entity call that was happening in the immersive view that returns the content root. So basically whatever is happening in the app model, say the world anchors are creating new entities, new objects, they basically get added as a child to the content root. And since we are adding the content root to the content here in the reality view, so this is what makes the entities we add in the app model visible to the user. So this is basically implementing a reality view with the make, update, and the attachments closures. So we'll kind of look into it in detail, but let's jump back into the app model and see all of the ARKit setup first. To do the ARKit setup, there is a lot of boilerplate code. You can see there are some like enums to basically handle error states and things like that. We basically create an ARKitSession, and in the ARKitSession, once we've created that, we also create a tracking provider, the WorldTrackingProvider. The WorldTrackingProvider provides us the world anchors, any events associated with the world anchors. It also provides us with the device position. We'll see some more boilerplate code here, like for example, it checks if the WorldTrackingProvider is supported, if the user has authorized any of these capabilities, and if the user denies it, you can basically handle it here. And then there is also like handling of the session updates, like for example, whenever the authorization changes, whenever there is an error in the session, something happened, tracking failed, anything happened, is all handled over here. And then there is running the session. So this is the important one, because here is where we are calling the ARKitSession .run function with the following provider, which is the WorldTrackingProvider. So when we call run, our ARKit kind of gets into action, and then it starts processing all the updates. you can see in the immersive view at the end I have some task modifiers, and here I'm calling all these functions. So they are async functions, so I'm awaiting them over here. So I'm running the session here, I'm monitoring the session updates, and even processing the world tracking updates over here. So this is the most important function because this is handling the adding, the updating, and the removal of the world anchors. So let's quickly look at it. We'll go into details of like what exactly is happening here, but let's first take a high level overview of it. So jumping back into the app model, now here you can see that we are doing processing of the world anchors, and there are different updates, and each update have different kinds of events. Like for example, there is addition, there is updating of the world anchors, and there is also removal. So we sort of handle all those events, right? So there is a different sort of paradigm here which we need to really understand in terms of like how entities are really added to the view. You might be used to this thing where you basically go into your reality view and simply add entities there, whether you are loading it from Reality Composer or someplace else. With world anchors, it's a little bit different. What happens with world anchors is you are not directly adding an entity to the content of the reality view. Instead, what you're doing is you're telling the world tracking provider that, hey, I want to create and add a world anchor. And when that world tracking provider basically detects this event of like, okay, you added a new anchor, this is where you create a new entity. Okay, this is where you create a new entity and you basically add it. Okay, so you're adding it to the content root. Here I'm not directly adding, I'm asking the world tracking provider to basically add the entity to my content root whenever there is a world tracking update and there is an addition event. Same thing, like I'm not really removing the entities, I'm looking for a world anchor removal event here, and whenever that event happens, I'm basically removing that particular entity. So you can see that I'm removing that particular entity from its parents, so it makes the sphere go away. This means that you need to add, update, and remove world anchors instead of adding entities. There are functions for that. So let's look into it. So how does this happen in the UI? So I'll show you the flow of it. In your content view, when you sort of enable the editing of the light setup by enabling the toggle, simply what you get these buttons of like add light control and add group control. So the addition of a new world anchor kind of begins when you press the button add light control or add group control, and let's exactly see what happens when this function gets called. You see that whenever we are calling this function, we first need to get the transform of this device. So here is the function just above it that provides us the current device transform. So again, you will see that the world tracking provider using this query device anchor at timestamp function gives us a device anchor. And from that device anchor, we can simply get a transform for the device using the device anchor.origin from anchor transform property. So once you have the matrix, you can get the device transform, and we can use it to figure out what is the forward direction from the device. So you can simply get these columns from the matrix, and from the second column you can get like the XYZ position, and this will basically give you the forward direction. We then normalize it. Also notice that there is a minus sign over here. That means we want to get, if there is not a minus sign, that means you're pointing behind you, not in front of you. So that's why there is this minus sign, and then you normalize it so you kind of get a direction that is pointing from your headset right in front. Then we have the current position. So basically the current position would be the device transform.translation, and from this translation you're basically multiplying with the forward vector, and you're basically adding the current position and the forward vector times 0.5, and this basically gives you a position in front of your headset. And you can change this 0.5 to say 1, and then it basically places the entity 1 meter in front of you. You basically create another transform from it. This transform is basically for where this newly created entity should be placed. So you're not creating the entity yet, you're just creating a potential position for where it should be placed. And then you call add world anchor, which is basically adding the world anchor. So we'll look at it, but there was one important thing that I missed that you should also keep in mind. So the .xyz is not available for free. Here I have defined an extension over here that basically gives you the XYZ property, and it basically returns like the XYZ position for the vector. So it's an extension for SIMD4. So now let's look at what happens when add world anchor gets called. So we are basically telling, can you please add a world anchor at this particular transform? And I am also saying that I want it to be a type of light. Okay, so the add group control is doing the exact same thing, but just like here it's saying that instead of adding a light, you're adding a group. So let's take a look at the add world anchor function. So we first need to just like create world anchor, and we need to give like where should it be. So here is the transform for where it should be. We have just created it, we have not added it. Our ARKitSession doesn't really know anything about it yet. Alright, so now you're seeing the mentions of the light control component. So we really need to see what it's doing. So why do we need the light control component? So the light control component is a component that you assign to the entity that is associated with the world anchor. And what this light control component is doing is basically creating an association between the world anchor and what type of light it's going to control. So you can see the code here for light control component. It's simply is a struct that is conforming to component, and then we have different variables defined here. I think the most important ones are which world anchor ID this particular component is going to be associated with, and then some state saving, like for example, is the light on? What is the ID of this light according to the Philips Hue API? What is the name of this light? So living room 3, living room 2, and then is it a component that is for controlling a light, or is it for controlling a group? So that's what we are doing over here. Okay, let's jump back here into app model. We instantiate the light control component, and in the light control component we basically assign the type. So when we are adding a world anchor, we say whether it's going to be a group or a light. So we basically assign it here, and we are assigning the world anchor ID here. So whatever world anchor you created, its ID. Okay, so you basically stored this information in this component, and then we are doing some disco for persisting the lights in storage. I'll talk about it in a bit, but then what happens is you simply call WorldTracking.addAnchor and you add this world anchor. So calling WorldTracking.addAnchor actually adds the world anchor into the system, and this is how ARKit and visionOS will basically remember it. You can see here that the WorldTrackingProvider doesn't really care about light control component. So we have simply created a light control component and we have saved it into the light info persistent manager. Okay. What is this guy? Why does it need to exist? So the world anchors, as I mentioned earlier, they are basically an ID and a transform, and it has no other information. So it's your app's responsibility to really figure out, like, once this ID and this anchor's transform gets returned, how does your app remember which light is it associated with? So the lights info persistent manager is basically that. You can see it over here. It's another manager. It has some like methods to persist the light information, like you can add light control information, you can remove, you can update. All it's doing is basically creating a file called lightcontrol.json, and it basically saves the light control information in this file whenever your app is kind of adding, updating and removing anchors. And then it also kind of locally stores it. So basically you can see that we are kind of keeping a light control component array here. This array simply stores all the light control components that are kind of present in your app right now. And this basically persists the association of a WorldAnchor ID and which exact light it's going to control. So right now, the light control component that we have created here in app model, so it doesn't have exactly the information of which light it's controlling. It only has the information of what type of entity it's going to be. It's only going to be either a light or a group, and it only has the information of the WorldAnchor. So it still doesn't know which light ID is it associated with, or what is the name of the light or the group it's going to be associated with. And we'll add that a little later. So what happens after you add anchor is you get an anchor update and you get this added event. In the added event over here, it basically gives you the WorldAnchor information, right? So we do have the idea of which WorldAnchor got added here. So what we are going to do is we are going to check in the light info persistence manager, and we are going to check this array of the light control components that we saw over here. So we are basically saying in this array, find the first one that has a matching WorldAnchor ID. Now what we are going to do is going to call the most important function that is actually going to create our sphere. So we are creating a light control entity here, and this is going to be the one that's going to be visualized. We are going to call create light control sphere, and we are going to pass the found light control component that is associated with this WorldAnchor. We also pass the WorldAnchor. So let's take a look at this function. So here you can see that it's a little bit familiar code. So we are generating a sphere mesh, we are generating a simple material, and we are basically checking the light control component type. If the type is of a light, then we color the material as red, and if the type is simply not light, which means it's a group, then we are coloring it green and kind of setting some other properties like roughness and metallic. Then we are creating a model entity with the sphere mesh, and then we are assigning the material here. And once we have done that, we are adding some more components to this entity, which is generate collision shapes, so that it can detect like collisions. Then we add an input target component here so that we can do inputs, like for example detecting tap gestures. Also notice that I am setting the allowed input types here on input target component as indirect. That means I only want it to be interactable using spatial tap gestures, not direct poking with fingers. And then you can set collision components as well here, so the input events can get detected. I also add an opacity component here. So here you can see that I'm checking with this flag that if it's editing the lighting setup, and then if the editing is happening, then the opacity is 0.5. If it's not editing, then the opacity is 0.05. So this is not how we are changing the transparency here. It's just like when you create it, if it's in edit mode, you make it less transparent. Okay. And then we finally set the transform based on the WorldAnchor's transform. So here the original WorldAnchor we created and the position we got in front of the user's face, we are generating the WorldAnchor's anchor transform, and then we are basically setting the sphere's transform to that. And then finally we are setting our light control component to our entity. And now this has stitched everything together. So now we have an entity that has the light control component that knows if the light control entity is basically controlling a light or a group. It knows its position, and it's associated with a WorldAnchor due to this light control component. So that's how the light control component is important, that associates light to WorldAnchor. You also saw that when I was toggling the edit mode toggle in the content view, what was happening is I was calling this function, which is toggle the visibility of light entities. So I'm basically going over all the entities that are saved, and in all these entities I'm basically finding its opacity component, and if it is editing the light setup, all I'm doing is setting the opacity to 0.5, and if it's not editing, I'm setting the opacity to 0.1. So this is how, when the toggle changes, you kind of change the opacity of the light control entities. So at this point, we have created an entity which is a sphere. It's going to be red if it's going to be controlling a light. It's going to be green if it's controlling a group. We know its kind of position and its association to a particular world anchor. That's all we have done. This entity still doesn't know which light it's going to control or which group it's going to control. So we still have to set that up. Okay, so after doing all of that, we create the light control sphere, and that gives us access to the entity. And now once we have done that, I have created some simple dictionaries that allow us to save the light entity and associate it with a world anchor ID. I also save the world anchor and associate the world anchor with the world anchor's ID. And then I finally add this light control entity that we just created to the content root, which then adds it to our reality views content. And that's exactly how the user sees the sphere that is created in front of them. So without this line, you will not be able to see the sphere. So you did all of this. We finally added the sphere in front of the user. Now you saw me that I basically dragged this sphere and I released it on top of the light. So this is how I was positioning it on top of a light, so I can control that specific light. Okay, so that means a drag gesture is involved. So where is that handled? We go back to the immersive view. Okay, and on the immersive view, I have set up a drag gesture, and here I am setting up the drag gesture so that it is only targeted to entities that has the light control component. We already just created a entity that has the light control component and a world anchor associated with it. So this drag gesture only affects those entities. Then whenever the value of this drag gesture is changed, we are basically changing the position of this particular entity. So that's how we are sort of dragging it and moving it. So when you're doing the drag gesture, you have to basically convert the value of the drag gesture from local to the entity's parent space, which is basically the content root. So we convert the value and set it to the position of the value entity, and that's how you sort of manipulate the entity and position it over the light. So you are still pinching and holding, you have not yet released yet. When you release, you see that the on-ended event gets fired. So here we are updating the world anchor with this new position, with this new value of this entity's position that the user has just manipulated and placed. So what does update world anchor do? So the world tracking provider doesn't really provide a method to update a world anchor. So instead what we have to do is basically remove an old anchor and add a new one. And what this means is basically that every time the user is dragging and releasing, when the release events happen, when the drag gesture ends, we are basically updating the whole world anchor. And what we are doing here is we basically trying to figure out what is the light control component associated with this world anchor. We are simply getting the handle of it. We are figuring out the type of it, and then we'll remove the older light control component from the persisted information for the lights, and then we remove the world anchor. Okay, and then we introduce a delay of 1 second, and then we finally add a new world anchor. This one is kind of important. You remember, like when I was demoing it to you, when I was done manipulating the particular sphere and when I actually dropped it on top of a light, the entity kind of disappears for a second, and this is why it's disappearing for a second. These are very separate events, removing a world anchor and adding a world anchor. And since they are asynchronous, right? So we need to introduce a potential delay so that the removal and addition doesn't sort of like happen simultaneously. So this basically ensures that we are cleanly removing the old one, and then after waiting we are adding a new one. So here you can see that when I'm adding an updated world anchor here, I'm providing it with a previous light control component. We want to look at both these methods, okay, again. So let's look at add world anchor again. Now when we are adding an updated world anchor, we are providing it with a previous light control component, and we are simply changing here. If the previous light control component exists, we're not creating a new one. Instead, we are simply updating the type, which is going to be the same, and then we are basically changing its world anchor ID. So now your light control component now knows the newer world anchor ID that is associated with this light control component. Then let's go back and look at what does remove world anchor do. So here we are basically telling the world tracking provider that please remove this anchor for this particular ID. When this particular thing happens, in the processing world tracking updates, we get another update event, which is basically a removal event. And the removal event basically is like removing the world anchor. So it destroys the light entity associated, the older light entity, which is what the remove from parent function will do. And then you basically remove that existing light entity from the stored dictionaries. And we are removing the light control component from persistent storage as well. And then again we'll create a new addition event. So the removal event happens and the new addition event happens, and that basically adds the updated version. So now you might ask, so why is there an updated event here? visionOS is through ARKit is providing any sort of like world tracking or world anchor updates, right? So let's say your room had low light, and then all of a sudden the lights turned on and your device sort of relocalized to the map. So the anchors were sort of a little bit off when your app launched, but now visionOS basically realized, oh, the map needs to be corrected. So visionOS basically corrects the map, and on a system level it basically updates the positions of the world anchor, and it creates an update event. So the update event basically means that the world anchor's position might be shifted a little bit. So all we need to do is update the position of the entity associated with the world anchor. So I hope this kind of gives you an idea of what is actually happening with like world tracking and world anchors especially, and how we can handle it with anchor updates. But in a gist, if you want to remember something from this, is basically that you in your app, you're basically adding a world anchor, and when that world anchor gets added over here, you are handling the addition, and when a removal event happens for the world anchor, which is right over here, then you have to handle the removal over here. And when this events get fired, this is where you sort of add or remove the entities from the scene. The most important thing to note here is that, and the mistake I did was I was not creating the entities in this particular function. Instead, I was creating the function entities when I was adding the world anchor manually, which is not the right approach. I think the right approach is only to create the entities here when your world anchor gets added and your world tracking provider gives you that update that it has been added. This makes a strong tie between an entity associated with a world anchor and doesn't separate those two. So at this point, you are able to simply drag and position the light control entities on top of the lights, and this basically updates the world anchor by removing and adding it. Even now, your entity doesn't know which exact light it is associated with. If you remember from the video, I did a spatial tap gesture on the entity once I positioned it, and then a UI appeared, and from that UI I selected which light it actually controls. So let's look at how that is done. So you saw me that whenever I do a tap gesture on a particular entity when it's in editing mode, what happens is a UI shows up right by this entity in which the user can set what group or light it kind of controls. So this is what we are doing over here. So when the tap gesture happens, we basically check what is the light control component associated with this entity, and then we set it in currently selected component. So in the app model, you can see that I have created some variables here to save the currently selected component that the user is interacting with. What is the type of it? What is the entity associated with it? And what is the name of the light control that is trying to control? Okay. So let's go back into immersive view. So basically when the tap gesture happens, I get the component and save it into currently selected component. I also get the entity associated with it and save it in selected right control entity. If we are editing, what I'm doing is I set the currently selected type, whether it's going to be a light or a group, and I get that from the currently selected component here, from the light control component. And then I basically set this show edit mode UI to true, and this flag, when it's enabled, presents the UI on the right side of the sphere that allows us to select which exact light or group does it control. So what is this UI? So here in the reality view, we have attachments, attachments are basically Swift UI views that you can basically convert into an entity. And then you can treat them like reality kit entities. So you can position them properly and associate these UI with other reality kit entities like a 3D model or something. Okay, so we are creating a UI as an attachment here, light config UI. We'll look at this view in a bit, but let's just see what's happening over here. When the reality view gets created initially, when we press show immersive view button, we are getting the entity for this attachment. We are setting an opacity component on this entity that is associated with the light config UI, and we are setting it to 0. So we are basically hiding this UI so that the user doesn't see it. You will probably wonder, does it only hide the UI, or if the opacity is 0, does it also make sure that the entity will not get any input events? That is absolutely correct. If the opacity component that is on an entity is set to 0, the entity will not receive any input events, no spatial tap gestures, no drag gestures. So this applies to any entity, not just UI. Just a tidbit there. So now we have created this, we have set its opacity to 0, so it's invisible right now. And then we are adding the light config UI to the app model. So here, if you remember, we created an empty entity to store the light config UI in the app model. So now we basically save it there when it gets instantiated. Then finally we add it to our content. So it's invisible, but it's added to our content. So whenever a spatial tap gesture happens, we need to make it visible. And that's exactly what we are going to do. State changes for reality views are kind of handled in the update closure of the reality view. So here, when the spatial tap gesture happened, so you can see it here, we are setting the show edit mode UI to true. When this happens in the update closure, we basically change the state. And then we call this function called position UI entity to face the user with animation. And we basically tell which particular entity we want to manipulate with this. So let's take a look at what's actually happening. So all this function is doing is presenting the UI to the user. In this particular function, what we are doing is we are setting up a show action and a hide action. These are basically animations. So I'm using a from to by action over here. So the show action is basically changing the value of the float to 1. The hide action basically changing the value to 0. So now you probably know for this particular entity, we are basically trying to affect its opacity component and changing it from 0 to 1 to present it. Here we are creating a show animation, which is an animation resource, and we are basically saying that make an action animation for this show action that we just defined above. The duration of this animation should be 0.25, and the bind target here is called the opacity property. So the opacity property is what the animation should affect. So what we are doing here is we first check, like, is the UI already open? Is the UI already visible? We get the entity's opacity component and its opacity value, and we check if the opacity is 1. If the opacity is 1, that means the entity is already visible. So we first play the hide animation on it. So we immediately do the transition, and then after 0.25 seconds, which means after the animation of hiding is done, we simply position the UI entity to face the user, and then we play the show animation. So we first play the hide animation and then we play the show animation. Okay, if it was hidden, we simply position it, no need to hide it, and just show it. Okay, and then what is this function doing? The position UI entity to face the user, all it's doing is again getting the device's current transform, which is the headset position, and we are doing the exact same thing, right? So we are getting the position of the user, we are getting the position of the light, and then we are basically calculating a direction vector, which you can get by subtracting the light position from the user position. So you get a direction that is going from the light to the user's face, and then you normalize it, and then you also calculate a right vector, which is basically, you can get it by doing a cross product, right? So you're doing a cross product between the direction vector and the up vector, and when you do a cross product, you get the vector that kind of points to the right, so you call it the right vector. We are getting the right vector because we want to position the UI to the right of the sphere. You can get a left vector as well. You just flip the direction and you can get the left vector as well. Again, you normalize this, and then I want to position it like 0.3 meters on the right. So I basically multiply the right vector by 0.3. Now I basically set the entity's position, which is equal to the position of the light, and then add the offset. So now what we want to do is basically make the UI face the user, and we can use the 8 and 2 function for this. We can simply use our direction vector, and when we pass our x and z coordinates to the 8 and 2 function, it gives us an angle on the y-axis, like how much on the y-axis our UI should be rotated. And then we can generate a quaternion by providing this angle and saying that the rotation is on the y-axis. That's why the y value is 1 here, and then assign this orientation to the entity. So we position it to the right of the sphere, and then we rotated it so that it faces the user. So we manipulated, we presented, and the UI is now showing. So let's take a look at our light config UI, but before we go into this, we need to take a look at the Hue control manager, because this is going to be responsible for providing the names of the lights and the groups for our UI to be populated. So when we look at the Hue control manager, here I have some like dictionaries over here that save the information for the lights and the groups, and also creates associations between an ID of the light and the name of the light, right? So here is an example. The ID could be 1 and it could be living room lamp, 2 could be kitchen bulb or something like that. This is what is creating the associations between the ID and the name of the light. This is basically storing all the lights and the groups. So when our app launches, right, let's go back to the app model and see what's happening. here in the init function, you'll see that we first load any kind of saved light control components from disk, and then here we check for some states, like for example, is the username for the Philips Hue bridge discovered? If not, we simply like keep trying. But then we call this Hue control manager find lights and groups function, and the find lights and groups function will populate these particular dictionaries. And then our UI, which is our light config UI over here, this is where it gets with what to populate our picker view with. Okay, so what is the purpose of this? So let's look at this view now. So it's a simple SwiftUI view. It has a close button. So we create a button that has like the trash icon. When the user presses this button, you simply remove the light or group control, which means that we are removing the entity and the world anchor associated with this particular thing, and then it hides the UI by doing some animations. So we have seen these actions before. Then it also has a close button that simply closes this UI. So it sets this flag to false and plays this animation, and has the X mark image. Then it has some information about what is the currently selected type, is it light or a group, and then it has the name of what is the currently selected light or a group that this particular UI is going to control. So the main component here is the picker. It's a standard Swift UI picker which has the picker style of wheel. And what we are doing here is we simply get the light names from the Hue control manager. We simply get the group names for the Hue control manager. And we basically check if the currently selected type is light, then we only populate the picker with the light names. If the currently selected type is a group, we only populate the picker with group names. So that's when you saw that when I opened the UI, besides the green sphere, it was only showing the group names. And when I opened it by a red sphere, it was only showing the names of the lights in the room. So this is how it's handled. So if you remember correctly, whenever we are in the edit mode and when the user is doing a spatial tap gesture on a red or a green sphere, what we simply do is we saved any sort of light control component on that particular entity in the app model's currently selected component variable. Now that we have it saved, and when the user changes the values on the picker in this particular UI, what we do is whenever a new value comes in from this picker that the user has chosen, we have simply assigned it to the name property of the light control component. So if we look at the light control component, when we created the world anchor, we created the light control component, we assigned the world anchor ID to it. Then we also assigned at the same time the type of the light control it's going to be, whether it's going to be a light or a group. And now finally in this picker, what we are doing is we are simply telling it what is the name of the exact light it's going to control. So this basically completes the connection between which light. It also tells you what kind of control is it. Is it a light or a group? And it also tells you which kind of world anchor is this particular component and hence the entity is associated with. So this tiny little component is actually doing a lot for us to basically connect all the dots. So let's go back in the config UI. So you simply assign the name, and when you assign the name, remember that it's a struct, it's a value type. So you have to assign the light control component back to the entity. So we are using our light info persistence manager to basically update the light control component as well. So now I want to really tell you that why this particular class, the light info persistence manager, is very, very important for our experience to basically be persistent across reboots. Okay, but let's see what's happening over here. So we are basically using the currently selected light control component and we are saving it to disk. So what happens every time your app launches? This particular class is very important for your app to remember what is the association between a world anchor, which kind of light it actually controls, and whether it's controlling a light or a group. So let's start from the app model's init function. So in the init function, you can see that light info persistent manager load light control components from disk is being called. So you see what is happening over here. It opens the file and loads this array with all the light control components that the user has previously saved. And all these light control components now have the information about the light it's controlling, whether it's a light or a group, and also the world anchor. So when your app launches and your world tracking provider is now active and is providing you events, your app gets all these added events for every single world anchor you have previously saved. So visionOS basically tells your app you have launched, you are in a recognizable space where you have previously saved some world anchors. Here are those world anchors, and whenever the visionOS provides these anchors back to your app on a subsequent launch, the added case in the world tracking anchor update gets triggered. And here, now what you're going to do is basically look at the array of the light control components right over here, this array, which now has the stored information of the file that we just decoded. So now when the added event happens, the world tracking provider is telling me that this particular world anchor with this ID is now added. So now we are using this completely filled light control component, which has the information that we need to control the light. And we are again creating this sphere entity. Now this gets newly created. So this is a newly created sphere entity, and we associate the light control component with it over here. So now every subsequent launch, you don't have to do anything else. The world tracking provider and the lights info persistence manager is repopulating all the information on the entity that allows you to control the lights. So the user kind of went through the process of setting up the lights in this space, and now after doing all of that, they have disabled the edit mode toggle. When that happens, and when the user does a tap gesture on this light, let's see what happens. So now what is going to happen is we do the same thing in the app model. In the currently selected component, we save the light control component, right? And we also save which particular light control entity the user is trying to interact with and performing the spatial tap gesture. And then we simply go to handle tap gesture when not editing. So let's take a look at this. So when the user does a spatial tap gesture, we are simply checking the light control component and the is light on property on that component. We are simply toggling it. So this is a boolean, and we are setting it to true or false depending what the previous state was. Since we are changing the light control component, we have to assign it back to the entity. So please don't forget this. Since we are doing changes to the light control component, what we need to do here is update the light control component in our persistent storage as well, so we know that a particular light control component has been changed. And then once we have done that, we'll check, is the currently selected component of the type of light? In the Hue control manager, we'll simply call control light with the light name. If it's not a light here, if instead it's a group, then we'll call control group, and we'll pass it the group name that is saved in the currently selected component. And then in the action or in the state, we can simply specify, can you please change the on parameter to the state of this particular component? And then you make this API call to Philips Hue, and that will result in the light being turned on or turned off. This allows you to control the lights and toggle them on or off. So that brings us to the end of the first part. I know very well that it was very intense and we did jump back and forth between a bunch of files, but I really hope that you understood how data is flowing between ARKit, world anchors, and in your app's views. So it's very important to understand that. I think the high level thing you need to understand is that whenever you're using world anchors, you don't create the entities. You basically ask the world tracking provider to add an anchor, and when the anchor gets added or removed, you have to handle the creation and deletion of the entities over there. So this is a very key point. All right, we are going to keep it a little simple in the next one. So you see that we already created this UI for light configuration where we select which light this particular entity corresponds to. We are basically using the same logic to present a color picker UI to control the colors of the lights. So that's what we are going to dive deep into the next one. It's going to be very simple because we are already done with the hard part of setting up the world anchors. All right, so I hope that you liked it. Please like and subscribe if you liked it. I hope to see you in the next one. Ciao.